Welcome everyone to the wonderful world of motorsport. Today, we invite you on an exciting journey through the history of rally racing, into the world of gravel, snow, and asphalt stages, where cars and drivers push the limits of physics. Rally is not only about speed and adrenaline. It is the perfect harmony of strategy, tech and engineering excellence. Did you know that the very first true rally event was held in 1894? Between Paris and Rouen? Covering a distance of just 126 kilometers? Where competitors had to be not only fast, but also reliable. Over the years, rally cars evolved dramatically. From early, 5.0-liter, naturally aspirated engines, through the legendary B Group era, with 500 horsepower monsters, to today's Rally 1 hybrid machines, producing over 500 horsepower, from a 1.6-liter turbo engine, combined with electric assistance. Rally history is also a story of technological innovation, from the rear-wheel drive, Alpine Renault A110, through the iconic Lancia Stratio SHF, to the all-wheel drive legends, Audi Kvyatro, and Subaru Impreza, leading to today's modern, hybrid Rally 1 cars. Each era marked a new milestone, new engine technology, aerodynamics, suspension, and electronics, shaping the future of the sport. Today, rally is more than world championships. The legendary stages of Monte Carlo, Finland, Sweden, and Wales are among the most technical roads in the world, where drivers test grip, speed, and tactical intelligence, all at the same time. In this video, we guide you through the most important milestones of rally history, the iconic cars, the legendary events, and the technological breakthroughs that turned rally into one of the most exciting and diverse forms of motorsport. (1894 to 1911), the early era of rallying. The history of car rallying goes all the way back to the late 19th century, when motoring was still in its infancy, and every race was as much a technological experiment as a competition. The first official car race was held in 1894 in France, between Paris and Rouen, covering a distance of just 126 kilometers. During this period, cars had only 4 to 12 horsepower engines, and average speeds barely exceeded 20 to 25 kilometers per hour. Drivers had to prove more than just speed. The reliability of their cars and their own skill were equally important. A single mistake or mechanical failure could easily mean disqualification. Early rallies were very different from today's high-speed races. Most roads were gravel, dirt, or stone, often difficult to pass, especially in rainy or snowy conditions. Navigation posed a serious challenge for drivers and their helpers. Maps, orientation, and correctly interpreting road signs could determine the outcome of the race. By the early 1900s, the first homologation and category systems had appeared. Race organizers were trying to introduce more precise rules. Vehicles were still small, 2- or 4-seater models, with inline 4-cylinder engines and manual gearboxes. Their weight typically ranged between 400 and 900 kilograms. Interestingly, in these years, drivers often took on the roles of firefighter, mechanic, and navigator. On long stages, they had to repair engines by hand, change wheels, or adjust the carburetor, all during the course of the race. Overall, the period from 1894 to 1911 laid the technical foundations of rallying. It was here that the principles of reliability, speed, navigation skills, and vehicle technology were established, forming the backbone of modern rally competition. The legends and models born in this era, such as the Panhard Levasseur or Renault Type AX, are not only part of motorsport history, but also inspired advances in automotive engineering. In the next segment, we will explore the 1912 to 1929 period, when rallies became not just technical trials, but true competitions, with speed and strategy playing an increasingly important role. But before we move on, it is important to mention that the first Monte Carlo rally was the first true rally competition. It was held in 1911, and became a true milestone in the history of rallying. The purpose of the event was to allow manufacturers and drivers to demonstrate not only the speed of their cars, but also their reliability and their navigation skills. Competitors had to travel from Paris, Lyon, Brussels, and other European cities, all the way to Monte Carlo, across varied and often dangerous roads. This event already foreshadowed that rallying would not simply be a series of technical trials, but a true challenge of strategy, endurance, and driving ability. Drivers faced a multi-day journey where every single kilometer mattered, and one mechanical failure or a navigation mistake could easily mean the end of the competition. This first Monte Carlo rally laid the foundations of modern rally traditions, and its famous routes, along with its technical and tactical challenges, continue to inspire drivers and fans to this very day. 1912 to 1929, pre-war legends. The next chapter in rally history covers the period between 1912 and 1929, often referred to as the pre-war era, or the age of pre-war legends. During this period, rallies were no longer just technical trials, they were real competitions, where speed and strategy played an increasingly important role. Races now consisted of stages between 200 and 400 kilometers, and car performance ranged from 20 to 60 horsepower. Although this may seem modest today, every horsepower counted due to the conditions of the roads and the weight of the vehicles. A Renault Type KJ or Mercedes 2895 race car would accelerate from 0 to 100 km per hour in 25 to 35 seconds, an impressive feat for the era. Cars were already equipped with 2- or 4-cylinder engines, often with mass-produced bodies, but with competition-optimized suspension and reinforced braking systems. Weights ranged from 700 to 1,200 kilograms, and drivers often had to maintain their cars by hand during long stages. During this time, rallies introduced various equipment and category systems to make manufacturer race cars comparable. The first homologated competition models appeared, forming the foundation for the future development of the sport. Interestingly, in pre-war rallies, stages were judged not only by speed, but also by reliability and navigation. Drivers often participated in multi-day events, where the goal was not just speed, but simply reaching the finish line. The precursors of modern rallies were already born at this time. The harmony between car and driver, strategic decisions, and technical expertise all became crucial. Iconic models of the era, the Mercedes 2895, Peugeot 201, or Bugatti Type 35, were not only milestones in rally history, but also in the development of the automotive industry. These cars already demonstrated the possibilities in engine and suspension development, and established the traditions of sports car rallying, which would grow and evolve explosively in the following decades. (1930 to 1949), the classic era of rallying. The period between 1930 and 1949 represents the classic era of rallying, when competitions became serious professional and technological challenges. This was the time when the sport began to gain international recognition, and manufacturers increasingly took racing seriously, as a way to showcase their cars. During this period, rally stages often covered several hundred kilometers, sometimes even thousands, and the roads were gravel, dirt, and cobblestone, extremely demanding for both cars and drivers. Car performance ranged from 30 to 120 horsepower, and vehicle weights were between 800 and 1,400 kilograms. Although absolute acceleration lagged behind later decades, durability and reliability became decisive factors. Iconic models of this era include the Lancia Lambda, Alfa Romeo 16C, and Bugatti Type 57 race cars. These cars featured advanced suspension systems, self-supporting bodies, and reinforced braking systems, designed to endure long and variable terrain. The Lancia Lambda, for example, was considered innovative as the first mass-produced car with a self-supporting body, which also provided an advantage in rallies. Interestingly, in the 30s and 40s, rallies relied not only on speed, but also on navigation, endurance, and technical skill. Drivers often had to repair engines themselves, change tires, and check suspensions during stages. Navigation was still based on maps and orientation, and the coordination between drivers and co-drivers was crucial. In the pre- and during World War II period, rallies became laboratories for technical innovation. Turbocharging and four-wheel drive were not yet common, but lightweight and strong aluminum bodies, suspension optimization, and engine development began to flourish. Overall, the 1930 to 1949 era laid the classic foundations of rallying, international competitions, manufacturer rivalries, and technological innovation, all contributing to the sport becoming a true global challenge in the decades to follow. (1950 to 1969), the golden era of rally. The 1950s and 1960s are often referred to, in rally history, as the golden era. This was the period when rally was still primarily a long-distance, endurance-based sport, but speed, technical development, and purposeful car design began to play an increasingly important role. During this time, competition cars were still based on modified production models. Manufacturers entered cars such as the Ford Cortina, the Saab 96, the Mini Cooper, the Volvo PV544, and early Alpine, Renault models, which became successful due to their lightweight construction and excellent handling. Power output typically ranged between 70 and 150 horsepower, rarely exceeding 180 horsepower. Vehicle weight varied between 700 and 1100 kilograms, and 0 to 100 kilometers per hour. Acceleration usually took 7 to 12 seconds. The focus was not on sprinting, but on endurance and controllability. Rear-wheel drive, RWD, was dominant. However, many successful rally cars used front-wheel drive, FWD, which offered significant advantages on snow and gravel surfaces. All-wheel drive had not yet become a part of rallying. Technically, the cars were simple: inline four-cylinder engines, manual gearboxes, basic suspension systems, and minimal aerodynamics. Rallies were often held at night, on poor roads, over long stages, where reliability was the deciding factor. The role of the co-driver was crucial. Detailed pace notes and local knowledge were often more important than raw performance. Drivers already made tactical decisions about tires, pace, and risk, but the sport was far more human-centered than it would later become. By the late 1960s, cars such as the Alpine, Renault A110 began to appear, leading rallying into a faster, more specialized era, and preparing the ground for the Group 2 and Group 4 period of the 1970s. Iconic rally cars and championship successes, 1950 to 1972. The period between 1950 and 1972 was the era of rally's formation, when there was no unified world championship yet, but the first true legends of the sport were born. Mini Cooper S, 1964 to 1967. The iconic winner of the Monte Carlo Rally. Its compact size and front-wheel drive set a new direction for snow-covered and technical rally stages. Ford Cortina Lotus, 1965 to 1966. The rear-wheel drive, lightweight, and powerful British sedan was successful in both touring and rally events, and laid the foundation for Ford's future rally successes. Saab 96, 1962 to 1968. Known for its exceptional grip and reliability, it won several international rallies and became a symbol of Scandinavian rallying. Porsche 911, 1968 to 1972. One of the strongest and fastest rally cars of the era, which took multiple European championship and international victories, even before the creation of the WRC. 1973–1981, Group 4 and the birth of the WRC. The period between 1973 and 1981 marked a major turning point in the history of rally. This was the era when the WRC, the World Rally Championship, was officially born, along with the Group 4 category. Group 4 regulations allowed manufacturers to develop homologation rally cars. Vehicles based on road-going models, but heavily modified with competitive racing technology. During this era, rally cars produced between 180 and 320 horsepower. Their weight ranged from 710 to 1200 kilograms, while acceleration from 0 to 100 kilometers per hour took approximately 4.5 to 6.5 seconds. Most cars still used rear-wheel drive, commonly known as RWD. But toward the end of the period, a revolutionary machine appeared. The Audi Quattro A1, featuring four-wheel drive, a technology that would soon transform rally forever. Among the iconic models was the Alpine Renault A110 1800, which became one of the first WRC legends thanks to its lightweight construction and exceptional cornering ability. The Lancia Stratos HF, producing up to 320 horsepower, with its short and compact body, became the true icon of Group 4. The Fiat 124 Abarth Rally dominated the homologation special category, while another defining car of the era, the Ford Escort RS 1800, with 250 horsepower and a weight of just 960 kilograms, secured multiple WRC titles and demonstrated outstanding British engineering precision. The Porsche 911 Carrera RS acted as a bridge between the GT and rally worlds, delivering 300 horsepower and remarkable stability on fast asphalt stages. By the late 1970s, rally technology began advancing at an unprecedented pace. Turbocharging, widened bodywork, early diffusers, and aerodynamic elements started to appear, significantly improving handling, grip, and overall performance. The era reached its defining moment in 1981 with the debut of the Audi Quattro A1. As the first four-wheel drive car in WRC, it didn't just increase speed. It redefined rally technology and changed the sport forever. This moment marked the end of the classic rear-wheel drive rally era, and opened the door to the next great revolution, the era of the Group B monsters. The Porsche 911 Carrera brought rear-engine traction and precision driving to Group 4 rallying. Its unique balance demanded skill but rewarded experienced drivers on tarmac and mixed surfaces. The Saab 99 Turbo was a true pioneer, introducing turbocharging to top-level rally competition. Its strong mid-range power changed how rally cars delivered performance. The Talbot Lotus combined lightweight construction with a high-revving engine. It excelled on fast, technical stages where agility and balance mattered most. Its success helped secure the 1981 World Rally Championship title. The Datsun 240Z proved that reliability and simplicity could win rallies. It was especially strong on long, demanding events where endurance was key. During the Group 4 era, rallying was becoming faster, but the rules still kept performance under control. Engineers were no longer looking for limits. They were looking for ways to go beyond them. When Group B arrived, technology was unleashed, and the wildest machines in rally history were born.
Schaut mal, ob der Hafen hinten okay ist, bitte. Der rechte.
Group B, the era of monsters. The period between 1982 and 1986 is known in the world of rally as the Group B era. This time marked one of the most extreme chapters in rally history, when technological limits were almost completely removed. During these years, World Rally Championship (WRC) cars produced close to 500 horsepower. combined with extremely lightweight bodies and radical aerodynamic designs. The Group B regulations allowed manufacturers to build homologation cars with only 200 to 400 road-legal units required. This freedom gave engineers nearly unlimited creative space to push performance far beyond anything seen before. Vehicle weight often ranged between 900 and 1,050 kilograms, while acceleration from 0 to 100 kilometers per hour took just 3 to 4 seconds, an astonishing figure at the time. Among the most iconic machines of the era was the Audi Quattro Sport, which revolutionized rally by introducing permanent all-wheel drive. Also legendary was the Lancia 037 Rally, a traditional rear-wheel drive car, representing the final evolution of a classic rally concept. Another defining monster was the Peugeot 205 T16, which combined a mid-engine layout with turbocharging, setting new standards for performance. Group B cars featured extreme aerodynamic elements, large rear wings, diffusers, and wide fender flares. All of these components were designed to maximize downforce and improve stability at very high speeds. This car demanded exceptional skill, as the thermal acceleration and immense power often exceeded human reaction limits. Despite the incredible technological progress, the period was also marked by tragedy. The combination of high power, lightweight construction, and underdeveloped safety systems led to several serious accidents. As a result, in 1986, Group B was officially banned. In summary, the Group B era remains the wildest and most unforgettable period in rally history. Turbocharging, all-wheel drive, and radical aerodynamics ensured that rally would remain one of the most exciting forms of motorsport. This era has permanently etched itself into the memory of drivers and fans alike. The Audi Quattro S1E2 represents the peak of Group B development. With a turbocharged 2.1-liter inline-5 producing up to 600 horsepower, it used permanent all-wheel drive to deliver unprecedented traction. Its extreme aerodynamic bodywork and short wheelbase made it brutally fast but difficult to control, especially on tight stages. The Audi Quattro A2 was the refined evolution of the original Quattro, featuring improved weight distribution, lighter body panels and approximately 350 to 400 horsepower. It established all-wheel drive as the dominant rally drivetrain. The A2 proved that AWD was not just an advantage, but the future of rallying. The Ford RS200 was purpose-built for Group B competition, featuring a mid-mounted turbocharged engine and a sophisticated all-wheel drive system. With up to 500 horsepower in rally specification, it delivered excellent balance and traction. Its advanced chassis design made it one of the best-handling Group B cars, but its late debut limited its competitive success. The Renault 5 Turbo took a different approach, using a mid-mounted turbocharged engine and rear-wheel drive. With up to 350 horsepower in rally trim, it delivered explosive acceleration but demanded exceptional driver skill. Its compact size and aggressive power delivery made it a legend on asphalt stages. The MG Metro 6R4 was one of the most unique cars of the Group B era. Unlike most of its rivals, it used a naturally aspirated 3.0-liter V6 engine combined with a permanent all-wheel drive system. Producing over 400 horsepower, it delivered instant throttle response and excellent balance. Although it arrived late and lacked extensive development time, the 6R4 became famous for its aggressive sound and raw driving character. Group B pushed rallying beyond its limits. Extreme power, minimal safety, and fearless drivers created legends, but also tragedy. By 1986, the FIA ended the category to protect lives. Group B didn't just change rallying, it redefined what was possible, and why limits must exist. 1987 to 1996, Group A, the era of turbocharged AWD dominance. The period between 1987 and 1996 marks one of the most influential chapters in rally history. After the dramatic end of the Group B era, the FIA introduced a new set of safety-focused regulations designed to protect both drivers and spectators, while preserving the raw speed and excitement that define the sport. This era became synonymous with the dominance of turbocharged, all-wheel drive Group A machines, cars that were safer and more predictable, yet still incredibly fast and technologically advanced. Typical Group A cars produced 300 to 350 horsepower, weighed 1,050 to 1,250 kilograms, and were required to use AWD systems, which revolutionized traction across gravel, snow, and tarmac. Acceleration from 0 to 100 km per hour hovered around 4.5 to 5.0 seconds, thanks to turbocharging, advanced differentials, and increasingly sophisticated engine management systems. For drivers, this era demanded precision, managing turbo lag, understanding the behavior of active suspension systems, and adapting to rapidly changing grip levels became essential skills. Among the iconic models of the era, the Lancia Delta Integral stood out as the multiple world champion and the undisputed king of Group A. Its compact chassis, aggressive turbocharged power delivery, and advanced AWD system created one of the most competitive rally platforms of the late 80s and early 90s. With real-world outputs around 300 to 330 horsepower and 350 to 380 Nm, the Integral set the benchmark for traction and agility. The Subaru Impreza Steve, developed by ProDrive, featured one of the most advanced technical packages of the era. Its 2.0-liter boxer engine produced 320 to 330 horsepower at 5,500 revolutions per minute and 325 to 339 lb-ft, 440 to 460 Nm, of torque at 7,000 to 9,000 revolutions per minute. The FIA-regulated 34mm restrictor fed an IHI VF15 turbocharger capable of 3-bar boost pressure. Combined with a ProDrive 6-speed pneumatic semi-automatic gearbox and active front/center differentials, the Impreza became a technological showcase of the early 90s. Its boxer sound, AWD grip, and iconic victories still define the true essence of rallying. The Toyota Celica GT4 represented Japanese engineering excellence. Its 3S GTE turbo engine evolved significantly across generations, delivering 300 to 340 horsepower in Group A trim. Toyota placed heavy emphasis on thermal management, intercooler efficiency, and drivetrain durability. The GT4's viscous center differential and robust cooling systems made it one of the most reliable and stable cars of the era. The Toyota Celica GT4 was an exceptionally controllable car on the stages, as you can clearly see in rally footage. And its engine note, that raw, turbocharged growl, is pure music to the ears of rally enthusiasts. Ford Sierra RS Cosworth 4x4, 1988. The Ford Sierra RS Cosworth 4x4 was a key Group A contender, especially on gravel and mixed surface stages. Its 2.0L turbocharged inline-4 engine produced 280 to 300 horsepower, with a curb weight of around 1,200 kilograms. The AWD drivetrain and Cosworth-developed engine delivered excellent traction and acceleration, 0 to 100 kilometers per hour in approximately 4.5 seconds. The Sierra 4x4 proved competitive in national and international rallies between 1988 and 1990. Its engine offered strong mid-range torque and responsive turbo behavior, making it ideal for technical rally stages. The Sierra 4x4 didn't just compete, it dominated. A machine that still thrills rally fans today. With its Cosworth engine, AWD system, and balanced chassis, the Sierra 4x4 became one of the most stable and competitive cars of the Group A era. Mitsubishi Lancer Evolution 6, 1996. The Mitsubishi Lancer Evolution 6 marked the peak of Group A development in the late 1990s. Its 2.0L turbocharged inline-4 engine produced 300 to 320 horsepower, with a weight of around 1,250 kilograms. The AWD system and active differentials provided excellent stability and acceleration, 0 to 100 kilometers per hour in approximately 4.3 seconds. Equipped with advanced aerodynamics, cooling systems, and rally-tuned suspension, the Evo 6 excelled on both gravel and tarmac. It was one of the final Group A homologated cars before the full transition to WRC regulations. Technological development. During the Group A era, the pace of technological innovation accelerated dramatically, and these advancements directly shaped the foundations of modern WRC cars. 1. Advanced electronic engine management. Early analog systems were replaced by digital ECUs, enabling far more precise control of fuel delivery and ignition timing. The Subaru Impreza 555, for example, used FHI/STI engine management combined with a GEMS data logging system. Fine-tuning of the ECU significantly reduced turbo lag and produced a smoother, more linear torque curve. 2. Evolution of turbocharging technology. Turbochargers received lower inertia rotors and more efficient wastegate control, improving responsiveness. Subaru's IHI VF15 Turbo could reach up to 3 bar of boost pressure, one of the highest values of the era. Lancia and Toyota also advanced water injection and intercooler systems to reduce thermal stress and improve durability during long stages. 3. Active suspensions and intelligent differentials. In the early 1990s, active front and center differentials appeared, capable of adjusting torque distribution in real time. Subaru's active differential systems were among the most advanced of the period, greatly enhancing cornering speed and overall stability. Suspension damping became adjustable, and geometry was optimized specifically for high-speed gravel and tarmac stages. 4. Improvements in braking systems and chassis geometry. Brake discs became larger and more heat-resistant, while pads used specialized rally compounds for consistent performance. Advances in suspension geometry made cars more stable in high-speed corners and more responsive to driver inputs. The Toyota Celica GT4 was particularly known for its strong and durable braking system, maintaining stability even on long mountain stages. The Group A era was also a golden age for drivers. Legends such as Juha Kankkunen, Carlo Sainz, Didier Auriol, and Walter Röhrl, Colin Steele-McRae, Tommi Mäkinen shaped the competitive landscape with their precision, adaptability, and mastery of AWD dynamics. The combination of turbocharged engines and sophisticated drivetrains created a new driving philosophy that directly paved the way for the modern WRC generation. In summary, the 1987 to 1996 Group A era represents a period of stability, speed, and technological refinement in rallying. It bridged the uncertainty following Group B and laid the foundation for the success of future WRC cars. Even today, it is remembered as a golden age of engineering brilliance and driver skill. Turbocharged, all-wheel drive machines became faster, smarter, and more refined, laying the technological foundation for the modern WRC. Engineers from Lancia, Subaru, Toyota, and Mitsubishi pushed innovation to new heights, defining the sport for decades to come. It was a decade where safety, performance, and engineering brilliance aligned, and the history of rally was changed forever. 1997 to 2016, WRC First Generation. The period from 1997 to 2016 marks the first modern generation of the World Rally Championship, characterized by a shift to highly specialized, purpose-built rally cars instead of modified production models. This era was defined by continuous technological refinement, turbocharged all-wheel drive dominance, and increasingly advanced mechanical and electronic vehicle control systems. First-generation WRC cars used 2.0-liter turbocharged inline-4 engines with a regulated 34mm air restrictor, limiting output to about 300 to 330 horsepower while maintaining strong mid-range torque. Anti-lag systems kept turbo pressure high even off-throttle, delivering rapid throttle response and explosive corner exits. Minimum vehicle weight was tightly controlled at roughly 1,200 to 1,350 kilograms including crew. With optimized gearing, AWD traction, and launch control, 0 to 100 km per hour times averaged 4.5 to 5.0 seconds, varying by surface. On gravel and snow, these cars often out-accelerated higher-powered circuit racers over short distances due to superior traction. Competition during this era was intensely competitive. Legendary drivers such as Sebastian Loeb, Marcus Gronholm, Petter Solberg, and Jari-Matti Latvala defined the period, while iconic cars like the Citroën Xara WRC Subaru Impreza WRC, and Ford Focus WRC underwent constant development. A key characteristic of the first-generation WRC era was the growing importance of aerodynamic innovation, lightweight chassis construction, electronic control systems, and engine optimization. These advances pushed vehicle handling and stability to a level where drivers could maintain extremely high speeds under nearly all rally conditions. Another defining feature of the era was the close collaboration between drivers and engineers. Continuous fine-tuning of suspension setups, tire selection, and engine calibration in the service park often proved decisive, with small technical adjustments translating into valuable seconds on each special stage. In summary, the 1997 to 2016 first-generation WRC era stands as one of the most technically advanced, exciting, and globally popular periods in rally history. During these years, rally cars evolved into highly specialized machines, combining turbocharged engines, all-wheel drive, and increasingly refined chassis design to deliver extreme performance on every type of surface. This balance of power, traction, and durability allowed drivers to push closer to the limits than ever before. Advanced aerodynamics and suspension systems played a major role in improving stability at high speeds and maintaining control on rough stages. At the same time, electronic engine management, anti-lag systems, and drivetrain optimization ensured strong and consistent power delivery, especially when accelerating out of slow and technical corners. These technologies not only improved performance, but also increased reliability over long and demanding rally events. The era was also defined by the growing importance of teamwork and professional race operations. Engineers and mechanics worked closely with drivers and co-drivers to adapt car setups to each rally, weather condition, and road surface. Strategic decisions, precise pace notes, and fast service times became just as important as pure driving skill in achieving championship success. Before we move on to the second generation of rally cars, it is worth taking a moment to look back at how the first generation of the WRC era came to an end. In 2013, the Volkswagen Polo RWRC was introduced, featuring a 1.6-liter turbocharged four-cylinder engine producing around 330 horsepower, with all-wheel drive. This car represented a major technical step forward compared to earlier first-generation rally cars. It was lighter, more efficient, and significantly more reliable than anything that came before it. The Polo RWRC delivered exceptional traction, refined suspension behavior, and precise handling, making it dominant on every type of rally surface. As a result, Volkswagen achieved multiple drivers' and manufacturers' championships in the FIA World Rally Championship. In 2016, the Hyundai i20 WRC made its debut, marking a turning point for Hyundai Motorsport. It used a similar 1.6-liter turbocharged engine with around 330 horsepower and all-wheel drive. What truly set it apart was a stiffer chassis, improved suspension geometry, and more aggressive handling characteristics. The i20 WRC provided greater stability at high speeds and stronger mechanical grip than Hyundai's previous rally cars. In summary, the 1997 to 2016 first-generation WRC era stands as one of the most technically advanced, exciting, and globally popular periods in rally history. The combination of turbocharged AWD machines, advanced aerodynamics, and elite teamwork elevated the sport to a new level and laid the foundation for the even more advanced second-generation WRC regulations introduced in 2017. Together, these factors elevated the sport to a new level and created some of the most competitive and memorable seasons in WRC history. The technical achievements and competitive intensity of this period laid the foundation for the even more advanced second-generation WRC regulations introduced in 2017, ensuring that the evolution of rally cars would continue into an even faster and more aggressive era. Together, these factors elevated the sport to a new level and created some of the most competitive and memorable seasons in WRC history. The technical achievements and competitive intensity of this period laid the foundation for the even more advanced second-generation WRC regulations introduced in 2017, ensuring that the evolution of rally cars would continue into an even faster and more aggressive era. 2017 to 2021, WRC second generation, the era of aerodynamics and technology. Between 2017 and 2021, Rally entered a new era with the arrival of the second generation of WRC cars, defined by radical aerodynamic development and significantly increased performance. The regulations allowed much greater freedom in bodywork design, resulting in wider cars, more aggressive aero packages, and substantially higher downforce, while overall vehicle weight was reduced and engine output rose to around 380 to 400 horsepower. Acceleration improved to approximately 0 to 100 km per hour in about 4 seconds, and all cars featured all-wheel drive, AWD. These technical advances allowed drivers to maintain exceptional grip and stability through corners and on loose gravel stages, while turbocharged engines delivered instant response and strong mid-range acceleration. This era made modern rallying truly spectacular. The increased aerodynamic grip allowed cars to brake later, carry more speed through corners, and exit turns with far greater acceleration. Drivers had to operate with extreme precision, because these cars left very little room for error. As a result, the second generation of WRC was not only faster, but also far more technically demanding and challenging than any previous era of rally competition. Iconic models of this era included the Toyota Yaris WRC, the Hyundai i20 WRC, and the Citroën C3 WRC. All of these cars featured state-of-the-art aerodynamic packages, and advanced suspension technology, rear diffusers, large rear wings, front splitters, and side air deflectors, all increased stability and downforce. The second-generation WRC era was not only about raw speed, but also about major technological innovation and precision in competition. Cars combined powerful turbocharged engines, advanced all-wheel drive systems, and sophisticated aerodynamics to reach a level of performance unseen in previous eras. Drivers could maintain exceptional traction and stability through corners, on gravel, snow, and tarmac, pushing the limits of both car and skill. Engine response, optimized differentials, and adjustable suspension allowed teams to fine-tune every car for each stage, maximizing speed while keeping control under the toughest conditions. Aerodynamic features like large rear wings, diffusers, and front splitters improved cornering grip and high-speed stability, while lightweight chassis and refined suspension geometry provided a precise and responsive driving experience. This era elevated teamwork and strategy. Engineers, mechanics, and co-drivers worked closely with drivers to adapt setups for surface, weather, and stage conditions, making every second count. The second-generation WRC era made rallying faster, more thrilling, and more technically refined than ever before, and it laid the groundwork for the next evolution. The Rally 1 Hybrid era introduced in 2022, bringing electrified powertrains, advanced safety, and sustainable innovation to the sport. (2022-present) WRC Plus, the Rally 1 Hybrid era. From 2022 onward, Rally entered a new era with the introduction of Rally 1 Hybrid and WRC Plus, combining sustainability, performance, and technological innovation like never before. Under the new regulations, Rally cars feature hybrid powertrains. A 1.6-liter turbocharged internal combustion engine works together with an electric motor, capable of delivering up to 100 kilowatts of instant power. Total output ranges between 380 and 500 horsepower, with a weight of approximately 1,260 kilograms, and acceleration from 0 to 100 kilometers per hour in around 3.5 to 4.0 seconds, showcasing the incredible speed and responsiveness of today's rally machines. All-wheel drive, AWD, and advanced electronic systems ensure maximum grip on every surface, whether asphalt, gravel, snow, or ice. Excitement and challenges that define rallying. Iconic models of this era include the Toyota GR Yaris Rally 1, Hyundai i20N Rally 1, and Ford Puma Rally 1, all equipped with the latest hybrid technology and aerodynamic packages. Diffusers, rear wings, and active aerodynamics provide high-speed stability, optimized acceleration, and precise cornering control. Interestingly, the Rally 1 Hybrid era is not solely focused on raw performance, it also places a strong emphasis on sustainability and efficiency. The integration of an electric motor reduces the mechanical load on the internal combustion engine, allowing it to operate more efficiently and reliably throughout the demanding rally stages. At the same time, the WRC Plus digital platform provides fans and analysts with real-time telemetry, including speed, acceleration, power distribution, and energy recovery data, making the sport more interactive, data-driven, and visually engaging than ever before. This combination of performance and accessibility has fundamentally transformed the fan experience, bringing spectators closer to the technical nuances of modern rallying. Overall, the 2022 present WRC Plus Rally 1 hybrid era represents the next evolutionary step in rallying, a perfect synthesis of sustainability, high performance, cutting-edge technology, and dramatic visual appeal. Hybrid powertrains, optimized energy recovery systems, advanced aerodynamics, and intelligent electronic controls work together to maximize acceleration, handling, and efficiency under extreme conditions. This era has elevated the sport to unprecedented technical sophistication, while preserving the thrill, unpredictability, and driver skill that define rally competition at its highest level. The future of rally. Over 130 years ago, in 1894, a few daring pioneers set out on rough, poorly constructed roads with simple machines, driven by a single goal, to reach the finish line. Little did they know, they were laying the foundation for a sport that would continually test the limits of human skill, mechanical innovation, and engineering precision. More than a century has passed since those first road races. Rally has endured wars, economic upheavals, and dramatic technological revolutions. It has adapted to new regulations, evolving terrain, and the ever-increasing demands of performance. Today, as we enter the hybrid era, rally faces a new set of challenges: how to preserve its raw, human-centered character while embracing technologies that support sustainability and efficiency. The Rally 1 hybrid technology marks only the beginning. The rally cars of the future will integrate multiple advanced systems, sophisticated energy recovery units, intelligent torque vectoring, adaptive aerodynamics, and AI-assisted setup optimization. Each system works in concert, enhancing performance while keeping the driver in full control. Modern rally seeks a delicate balance between heritage and innovation. Technology continues to advance, hybrid systems are becoming more efficient, all-wheel drive architectures are smarter and faster reacting, electronics provide real-time data to guide strategic decisions, and active aerodynamics adapt dynamically to the track and environmental conditions. But these innovations do not replace human skill, they amplify it. The driver's intuition, the navigator's precision, and the team's engineering decisions remain central to success. The future of rally depends not on a single breakthrough but on the simultaneous evolution of multiple technological and operational domains. Powertrains will be optimized for efficiency and responsiveness. Hybrid units recover and deploy energy intelligently, boosting acceleration out of corners and reducing fuel consumption across stages. The all-wheel drive system will evolve into an even more sophisticated platform. Advanced torque vectoring and wheel-by-wheel control will maximize traction on variable surfaces, from loose gravel to icy mountain passes. This allows drivers to exploit the car's potential while maintaining stability and precision. Electronics will play an increasingly crucial role. Sensors and telemetry will monitor grip, wheel slip, suspension load, and energy distribution in real time, providing insights to the driver and engineers. The vehicle's software will make micro-adjustments that optimize performance without overriding human decision-making, preserving rally's essence as a driver-focused sport. Aerodynamics will also become more adaptive. Active elements such as movable wings, diffusers, and spoilers will respond continuously to speed, cornering forces, and surface conditions, improving downforce and stability while maintaining optimal drag. This will allow cars to maintain higher speeds on straights and improved control in tight, technical sections. Sustainability is increasingly central to rally's development. The goal is not to sanitize the sport but to reduce environmental impact responsibly. Hybrid systems allow cars to use less fuel, distribute energy more efficiently, and reduce local emissions on special stages. Synthetic fuels and biofuels enable the internal combustion engine to continue contributing to performance while minimizing the carbon footprint. Rally is not a public transportation project, it is a real-world laboratory for automotive innovation. Technologies developed for competition often migrate into consumer vehicles, from energy management to chassis design, advanced aerodynamics, and safety features. Material science is progressing alongside mechanics. Lighter, stronger chassis and composite structures increase driver protection without compromising speed or agility. Safety innovations ensure that even when cars push limits, the risk to human life is minimized. The future of rally emphasizes precision, efficiency, and adaptability. Driver choices, navigator accuracy, and engineering expertise continue to determine outcomes, often down to fractions of a second. A misjudged corner, an incorrect tire choice, or a poor energy deployment strategy can still prove decisive, as it has for over a century. Rally develops in the areas that truly matter: enhanced safety, intelligent energy utilization, and technology that adapts seamlessly to asphalt, gravel, snow, and ice. The sport's progression is measured not just in speed, but in the ability to manage complexity under pressure. The rally cars of tomorrow will be faster, more accurate, and smarter, yet no less demanding. They will challenge drivers to master advanced hybrid systems, adaptive aerodynamics, intelligent AWD, and real-time analytics, all while preserving the essential human skill at the sport's core. Because rally has never chosen the easy path, it continues to test the synergy of man, machine, and environment. Even after 130 years, the fundamental question remains: who can master the car, the road, and themselves most effectively? As we have seen, the history of rally, from its simple beginnings to today's hybrid Rally 1 cars, has been an incredible journey. We explored legendary models, the monsters of Group B, the dominance of turbocharged, all-wheel drive, and modern aerodynamic masterpieces. All of this is the perfect combination of technology, driver skill, and engineering brilliance. If you enjoyed the video, hit the like button to let us know you'd like to see more content like this. Don't forget to subscribe to the channel and turn on notifications so you'll be the first to know about the next rally history video or other automotive content. Let us know in the comments which rally era or iconic car is your favorite and why. We love reading your opinions and experiences. Thank you for joining us on this exciting journey through the history of rally. See you in the next video. Stay with us in the world of speed, technology, and the legends of rally. Rally was born from courage, noise, dust, and raw mechanical power. Legends like the Audi Quattro S1 proved that innovation can change the world, not by looking back, but by daring to go faster than anyone